Hello world viewers, what's up? I hope all you are doing well and your neos and deos are also doing well. So this video is about a lot of days gap due to some reasons, and there is a big plan ahead for my this channel. I want to explore to new various things and experiment on this channel. That's why I took some times to a better qualities video in near future, and because of the series is unended, that is the derivation of Maxwell equations. We are going on that for, right? So that's why I am here to complete those series that remained. That's why I am here, and today I am going to derive the fourth equation of the Maxwell equation. Okay, so irrespective of that, first of all I convey my best regards and heartful thanks to all of you, those who are watching my videos and previous videos, because it will be more helpful to understanding a concept, whatever the concept. So for the future endeavor, I have a lot of manifesto and I have a lot of things to share with you. That's why I took some times and took some break, and I am also continuing my other studies as well regarding my other professional studies. That's why I took some times. That's why this video is late for that reason. And today we are going to derive the equation. Let's see whatever how this equations is going to be derived. So what is the fourth equation of Maxwell? That is curl of H is equal to current density plus displacement current. You know what is this? That is H is the magnetic field intensity. We know about this. H is the magnetic field intensity. Okay, and J is the current density. J is the current density. So we're gonna to derive this equation. For this we need to have some pre-knowledge before it, because directly we can't derive this equation because we need some pre-knowledges. And what are the pre-knowledges? That first is we need to know what is equation of continuity. What is equation of continuity? To actually know what is the equation of continuity, we will know it, because it is one type of checking the validity of that equation. Is it right or wrong? But whatever, for that we need to verify those equations by this equation of continuity. Then this equation is based upon in which favor? That the second things we need to understand is the Ampere's circuital law is the second thing, because this equation is based upon this particular equation. That's why we need this pre-understanding about what is Ampere's circuital law. And then third is vector identity. Vector identity. So what is vector identity? Especially a simple formula will be used, that is A dot B cross C. A dot B cross C is equal to 0. This formula is already has been done in the vector classes, in the vector sections, in mathematics section, and it has the proof. Still we will use here because the curl of something with the divergence will be 0. That is the things we're gonna use. Stokes curl theorem. So what is Stokes curl theorem? Stokes curl theorem is about to convert the linear integral to surface integral and the surface integral to linear integral. That's the application of these equations. And the last thing will start, that is displacement current. So displacement current will be discussed about that regarding the stages of this equation during the derivation. We'll discuss everything. So stay tuned with me. This equation is based upon Ampere's circuital law. Ampere's circuital law. What is this? What is Ampere's circuital law? Is that the linear integral of B dot dl is equal to mu I. Okay, so what is the B? B is the magnetic field, we all know, and it is a linear integral when it is in closed surface, and it is actually the Ampere's circuital law. We all know about it, and in previous videos I also have discussed about it. If you don't know, then okay, you can watch it. So when it comes to the mu, actually is mu, then it is permeability. Permeability on free space. Permeability in free space. Okay. So this is the meaning of this mu. Okay. So when it comes to this much, and we will know what is the permeability. It is about permission in having some kind of things or surface. It is one kind of permission. It kind of doorstep. It is also present in our human cell as well. Cell membrane is also act like a permeability. That's why it is also a permeability in this case, right? So that is B is equal to mu naught H. B is equal to mu naught H, and this is also mu naught. From that derivation, actually B is equal to mu naught H. B is the magnetic field and H the magnetic field intensity. H is the magnetic field intensity. Magnetic field intensity. So we'll apply it in this equation. Actually, in this equation, we're gonna apply this, and what will be that? Linear integral of, and B we can replace it as mu naught H dot dl is equal to mu naught I. Okay. So this much we can use it here, and mu naught will be a constant, so we can take it outside of it and we can cancel it out in both sides, because constant will be out from this variable sections, though we can out it from this side, so the mu naught will be cancelled out from the both side, right? So mu naught will be cancelled out, then the remaining will be linear integral of h dot dl is equal to I, and in place of I we can right now I is equal to surface integral of j dot ds. So this is called the current, which is the integral of current density, the surface integral of that current density, by which we can get it. Okay, so in this place of I can write, because mu naught is already cancelled out, so we can replace I as surface integral of j dot ds, right? So this is the outcome we get here. Okay, then there is a thing we need to understand here, that there is a linear integral and there is a surface integral. So to get something result, we need to we need to do the same integral form in the both side. So what is that things we'll use here? That's I told you in the sense of the pre-knowledge video. I can say that we should use the Stokes-Cole theorem. What is that? Stokes-Cole theorem. Now what is the role of the Stokes-Cole theorem? It is about to convert linear integral into surface integral and surface integral into linear integral. So this is the LHS, this is the RHS here. So using Stokes-Cole theorem in LHS, we can use it on the side. So we can use in the LHS. What will be it? Then it will be that surface integral, linear integral will be converted into surface integral and vice versa. Okay, so h dot dl is here. So using this Stokes equation, it will be converted into dl to ds. So first state it will be ds, okay. So integral of col of h dot ds, okay, is equal to surface integral of j dot ds. Surface integral of j dot ds we got here from this side. Okay, so this equation is like this due to we use the Stokes-Cole theorem. Right hand side is already the same. We use it in the to the left side. What will happen if we took it to the left side? It will be implies minus j, and this will be ds is equal to 0. So the integral and the ds, integration of ds will be 1, integration of ds that is equal to 1. So this part will be 1 and 1 will be going to another side, 0 divided by 1, that is equal to 0. So we can write the call of h minus j is equal to 0, implies we can write call of h is equal to j. So this is the equation we got from this. Let's say this is the equation 1. So this is the equation 1. Call of h is equal to j. The j is the current density. So what we'll need to do is that, is this equation is correct, or is the equation is valid or not? That is a very big question for me as well, the Maxwell. Then he came to something new that I told you about in the previous section, that in pre-knowledge, that we need to verify this, we need to validate this. So to validate this equation, to make it valid this equation, what he does using the equation of the continuity. Using the equation of the continuity to validate. So to validate equation 1, we use equation of continuity. So what happened in the equation of continuity, that is that in equation of continuity they just took the divergence in the both side. They took divergence in both the side. The equation of continuity happens, then they took divergence in the both side. Taking divergence in equation 1, what will happen? That divergence of curl of h is equal to divergence of current density. Okay, so divergence of curl of h is equal to divergence of current density. So what will happen here is that this fact will be 0. As you know, I told you before that in case of vector section, we all know that a dot b cross c is equal to 0. We will know it in the vector section, it is also in the same, but in case of this, it is called as the curl and it is called as the divergence. That's why when it in the call section means it is in rotational section. If something is going on the rotation, and if we talk the divergence here, then the result will be 0. That's the after experimented result. I am telling you in a single word. So this part will be 0. This part will be 0. So we can say divergence of j is equal to 0. But what happens when we are gonna to verify any kind of equations? If the result is 0, then we can't say this equation is valid. The equation is not valid. That's why something is lacking here. So Maxwell noticed something is lacking here. That's why this is not valid. Okay. So what happened in the next step? We'll notice it. Okay. Here the equation is not valid because the output is 0. So from the equation of continuity, this result should not be 0. I mean, the divergence of j never ever should be 0. It should be anything but not 0. Okay. So what it does in the next stage, we'll notice here. If it valid, Maxwell is going towards his new concept, is displacement current. I will know about displacement current. I have also discussed about in the previous lecture. Still, I repeat it. That what is displacement current? When a capacitor is in the series. When a capacitor is in so this series, and this is a capacitor, we know it, and in between that is a electrostatic rod is there also. We can say in between this, we say that there is no current is fast. Previous scientists are not noticed about this, that in between the capacitor there is no electricity flow. But in case when it comes to Maxwell, he noticed that some electrons are also passing through this. Some electrons are also passing through this medium. That's why he told that there is also a current in between that, and he termed that current is that displacement current that is between the capacitors, and he termed as JD here. So what is the equation 1 we wrote? That curl of H is equal to J on that case. Here he adds something new, that is the displacement current density, that is JD. Okay, JD. This is the new equation after the equation 1. This is the equation 2. What was the equation 1? Equation 1 is that curl of H is equal to J. But it is not valid. We have tested it as the output is 0. That means this equation is not verified. It is not valid. So he took something new, that is the displacement current concept here. Who? That is Maxwell. So we need to we're gonna to verify this again. So we will use the equation of continuity again. Equation of continuity. So we'll took divergence in the both side. I told it before also. Divergence of curl of H is equal to divergence of J plus JT. That will be divergence of J plus divergence of JT, and this term will be 0, will know. That is because the divergence is happening in between a curl which is in the rotation. That means this term will be 0, and that is also we will know, that is vector identity equations. We will know A cross B, A dot B cross C. Okay, so this term will be 0. That means implies that divergence of J is equal to minus of divergence of JT. So we will notice here that divergence of J is not equal to 0. It is something that is minus divergence of JT. That means here this equation is verified. This means the equation 2 is established or valid. So things that here we have found out that this equation is valid as divergence of J is not equal to 0. So the next step will be definitely comment out what is the value of JT. So to find the value of JT, then Maxwell does something new, not something new, but it has the values already. So it just reflects something, that is he will use the Maxwell first equation and he will use some formulas which has been used before. So he just replaced those things and the things will be ready. So it is an easy process and easy thing. It may be looks lengthier, but the process is very easy. Okay. The relation is that divergence of current density is equal to diverty of rho, that is volume charge density. This relation we all know before. Okay, so we'll just use that in here. Okay, so what will happen? It will be that V dot J, and then it will be replaced as, sorry, this will be minus sign. So it will be minus, what is the equation is that is equal to minus of divergence of JT. So we have to find out this value. This is our motto here. We have to find the value of JT. Then this part is that minus diver rho upon diver T, that's equal to minus divergence of JT. So this is the minus will be cancelled out. Then the rest things will be diver rho from diver T is equal to divergence of JT. JT is the displacement current. To look at the Maxwell first equation here, because the rho is here, the volume charge density is here, and we know in the first equation that is a relation in that. So we can replace the rho here, that diver T, what is the rho? That is divergence of D, that is equal to JT. So recurrent factor is that we'll took it that left side. So it will be divergence of JD is equal to, then the divergence will become outside, the divergence of diver D upon diver T. Okay, diver D upon diver T. So here the divergence symbol will be cancelled out from the both side. So divergence will be cancelled out. Then the factor will be that JD is equal to divert D upon divert T. Okay, divert D upon divert T. So what is the value of that displacement current? Is that JD is equal to divert D upon divert T. Okay, so what will be the final value? The equation is from the second side is that curl of H is equal to J plus JD. So what is the value we got from here is that JD is divert D upon divert T, implies curl of H is equal to J plus divert D upon divert T. This we verified and we got it. So it looks lengthier, but it is very simple if you notice here, because every steps are we all know before. So if you don't know the previous knowledge, then it will be very much complicated to us. If we look the previous videos, then you can feel yourself that it is very much simple. So it is about to over what is that electromagnetic field theory, both integral and differential equation I have derived here. And for the next step I am thinking what will I do, and I have already planned, but I am doing something new project, right? So it is about a going on process. So keep with me and keep subscribing this channel, keep sharing this channel, make a crowd of this channel. And I have a lot of plan here to establish something new concepts and something new derivations as well, and something creativity from my side, and some equations are going on my mind, and I just want to show you on that cases. And after all, I am here concluding this video by saying thanks you for watching this video.